Good evening, students. Welcome back to Sunine Sir's online classes. In this video, I am going to explain you refraction at curved surfaces part 3. In this, the topics which I am going to cover are curved surface formula, lens formula and lens maker's formula. First, let us see curved surface formula. Before going to curved surface formula and lens formula, first we need to know about sign convention. Sign convention. So in this we know that convex lens forms real images, and in one case it will form virtual image, whereas concave lens always forms virtual images. So real images are always inverted and virtual images are always erect, and focal length of the convex lens is taken as positive, whereas focal length for concave lens is negative. When object is placed left side, for example, if this is convex lens, then compare this with coordinate axis. That is, for coordinate axis, right side is positive x-axis and left side is negative x-axis. Similarly, if this is concave lens and when object is placed left side, so object distance is from the center of the lens to the object, that is u. So since we are placing object left side, so u is always negative because left side is negative x-axis. So u is always negative. Whereas if image forms right side is positive x-axis, that is why v is positive. If image forms left side, that is if virtual image forms, then v is positive. So simply what I would like to say is, if you take a lens and if you place a object left side, whatever the object is there on left side, so that is negative, and whatever it is there on right side, it is positive. It means we'll place always object on the left side only, that is why u is always negative, whereas v in some cases it will form right side, that is when it is forming right side, it means it is a real image. In case of real image, v is positive, whereas in case of virtual image, v is negative, because virtual image will always form on the same side of the object, that is it will form this side means it is negative. So in case of virtual image distance v is negative. In case of real image distance v is positive, whereas object distance is always negative. Object distance is always negative. So u is negative, v may be either positive or negative. The same thing I wrote here. Object will be placed left side, object will be placed left side, that is why always u is negative. Whereas if image forms on the right side, v is positive, that is real image means v is positive, and if image forms left side, then if it is virtual image, then v is negative. So this is sign convention. Now let us see curved surface formula. If light is entering from one medium to another medium, if light is traveling from one medium to another medium through a curved surface as shown in the figure. So here this is a curved surface, and when light is traveling from one medium to another medium, at this point, since there is change in medium, light ray will undergo refraction. It will undergo refraction. Instead of going straight like this, it will undergo refraction, and when it is undergoing refraction, we have one specific formula. That formula is nothing but curved surface formula, and it is given by n2 by v, n2 by v minus n1 by u, n2 by v minus n1 by u is equal to n2 minus n1 by r, n2 minus n1 by r, where r is radius of curvature, v is image distance, and u is object distance, n2 is second medium, and n1 is first medium. This curved surface formula is very important regarding 1 mark and 2 marks. They will ask curved surface formula and they will ask to explain each and every term. So v is image distance, u is object distance, r is radius of curvature, n2 is second medium, n1 is first medium. Next, now let us see lens formula. Lens formula is nothing but relation between v, u, image distance, object distance, and radius of and focal length f. When an object is placed in front of lens, then its image will form. We know that whenever we place an object in front of lens, it will form an image, whether it may be real image or virtual image, depending on type of lens and depending on distance of the object from the lens. Now relation between object distance, image distance is given by lens formula, and it is given by 1 by v minus 1 by u is equal to 1 by f. So this is general equation for lens formula. This is general formula. This is very general formula. We cannot apply this to the lens directly. We cannot apply this directly. In order to apply this to the lens, we need to apply sign convention to this general formula. To this general formula, we need to apply sign convention. So after applying sign convention, this formula will change as for convex lens. For convex lens, it will change into 1 by v plus 1 by u is equal to 1 by f. So if in the question convex lens is given, then you need to use this formula, because in this formula we already applied sign convention. So you should not use 1 by v minus 1 by u is equal to 1 by f. You should not use this formula while solving problems, because in this formula we did not apply any sign convention. So after applying sign convention of convex lens, we deducted this formula. So for convex lens, we need to use this formula, 1 by v plus 1 by u is equal to 1 by f. And for concave lens, the formula will change as 1 by u minus 1 by v is equal to 1 by f. This formula you need to use for concave lens. For convex lens, you need to use this formula. Whereas this is general formula. This is general formula. This is formula for lens formula for convex lens. This is lens formula for concave lens. So remember all the three formulae. Now let us see some problems. First, problem 1. Find the image distance of convex lens if object distance is given as 30 centimeters and radius of curvature is also given as 30 centimeters. So we know that radius of curvature r is equal to 2f. Radius of curvature r is equal to 2f. R is given as 30 centimeters. It means 30 is equal to 2f. From this, f is equal to 15 centimeters. And object distance u is equal to 30. Object distance is also given as 30 centimeters. Now we need to find image distance, that is we need to find v. So we know that lens formula is 1 by v minus 1 by u is equal to 1 by f. But this is general formula, so you should not use this general formula. You need to use lens formula for convex lens, because in the question it is given convex lens. So use convex lens formula. So convex lens formula is 1 by v plus convex lens formula is 1 by v plus 1 by u is equal to 1 by f. 1 by v plus 1 by u is equal to 1 by f. So f is equal to 15, u is equal to 30. Let us substitute these values. So 1 by v. So 1 by v plus 1 by u is given as 30 centimeters is equal to 1 by f. 1 by f is 15 centimeters. So 1 by v is equal to 1 by 15 minus 1 by 30. From this 1 by v is equal to, if you take LCM and if you simplify this, you will get 1 by 15. Sorry, this is 1 by 30. So from this you will get v is equal to 30 centimeters. So image distance is, it will be at a distance of 30 centimeters. Next, let us see one more problem. Find the image distance. Find the image distance of concave lens if object distance is 30 centimeters and focal length is 30 centimeters. So here what you need to find is, you need to find image distance v we need to find. Given that object distance u is equal to 30 centimeters, u is equal to 30 centimeters and focal length f is also 30 centimeters. Focal length f is also 30 centimeters. So here we know that lens formula for concave lens is 1 by u minus 1 by v is equal to 1 by u minus 1 by v is equal to 1 by f. It is 1 by f. So on substituting these values, u is 1 by 30, u is 30 centimeters, u is 30 centimeters, that is 1 by u is 1 by 30 minus 1 by v is equal to 1 by f. F is also 30 centimeters. So 30 and 30 gets cancelled, 1 by 30 and 1 by 30 gets cancelled. So 1 by v is equal to 0. From this v is equal to infinity. V is equal to infinity. It means image distance is infinite. It means image will form at the infinity. This is the case when object is placed at focus. So whenever object is placed at focus, then image will form at infinity. I think you remember this case. So when object is placed at focus, image will form at infinity. So here in the question also you can observe that focal length is 30 centimeters and focal length is 30 centimeters and object distance is also 30 centimeters. It means object is placed exactly at focus. It means image is formed at infinity. So now let us see lens maker's formula. Lens maker's formula. The relation between focal length and radius of curvature of the lens is given by lens maker's formula. So lens maker's formula is given by 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. So n2 by n1 minus 1 into 1 by r1 minus 1 by r2. This is general equation. This general equation we should not apply in case of problems. In case of problems we need to apply that specific equation. So for convex lens, this formula will change into 1 by f is equal to n2 by n1 minus 1 into 1 by r1 plus 1 by r2. So this formula will change as n2 by n1 minus 1 into 1 by r1 plus 1 by r2 for convex lens. Whereas for concave lens, this formula will change into 1 by f is equal to same as that of convex lens, that is n2 by n1 minus 1 into 1 by r1 plus 1 by r2, but in front of this formula there will be minus sign indicating that focal length will be negative for concave lens, indicating that focal length will be negative for concave lens. So that is 1 by f is equal to minus of n2 by n1 minus 1 into 1 by r1 plus 1 by r2. This is the formula for concave lens, lens maker's formula for concave lens. For both convex and concave the formula will be same with just a negative sine in a concave lens. Let us see one problem. So problem 1, find the focal length of convex lens whose radii of curvature is 15 centimeters and made up of glass. Made up of glass, we know that refractive index of the glass is, that is n2 is equal to 1.5, and here this lens is placed in air. Air means n1 is equal to 1, and radii of curvature is given as 15 centimeters. It means r1 is equal to r2 is equal to 15 centimeters. Now we need to find focal length of the convex lens. So in order to find focal length of the convex lens, we have lens maker's formula. For convex lens we need to apply, that is n2 by n1 minus 1 into 1 by r1 plus 1 by r2. So on applying this formula, 1 by f is equal to n2 is second medium, that is refractive index of the glass, by first medium is air because this lens is kept in air. So 1.5 by 1 minus 1 into radii of curvature is given as 15 centimeters, 1 by 15 plus 1 by 15. So this is 1 by f is equal to 1.5 minus 1, that is 0.5 into 1 by 15 plus 1 by 15, that is 2 by 15. So this is 0.5 into 2 is 1. 1 by f is equal to 1 by 15, whereas f is equal to 15 centimeters. 15 centimeters. So this is how to solve problems. In this way you need to solve problems. Next, one more problem, that is find focal length of concave lens whose radii of curvature is 20 centimeters and made up of glass. Glass means n2 is equal to 1.5 and n1 is equal to first medium is taken as air. If nothing is given, it is kept in air, it is taken as air, and radii of curvature is given as r1 is equal to r2 is equal to 20 centimeters. So we know that lens maker's formula for concave lens is 1 by f is equal to minus of n2 by n1 minus 1 into 1 by r1 plus 1 by r2. So on substituting these values in this formula, 1 by f is equal to minus of 1.5 by 1 minus 1 into 1 by 20 plus 1 by 20. So this is minus of 1.5 minus 1 is 0.5 into 2 by 20. 0.5 into 2 is 1. So this is minus 1 by 20. So focal length is 1 by f is equal to minus 1 by 20. So f is equal to minus 20 centimeters. So minus sign indicates that it is a concave lens. So in this way you need to solve problems. Next, let us see one more problem, that is find focal length of plano-concave lens whose radius of curvature is 20 centimeters and made up of glass. So in order to find focal length, we have formula 1 by f is equal to, for concave lens maker's formula is 1 by f is equal to minus of n2 by n1 minus 1 into 1 by r1 plus 1 by r2. So here second medium is glass, that is n2 is equal to 1.5 and n1 is equal to 1. Since it is plano-convex lens, so r1 is equal to infinity. First surface will be infinite, radius of first surface is infinite, and radius of second surface is r2 is equal to, it is given as 20 centimeters. R2 is given as 20 centimeters. Plano concave lens will be in this way. So first surface will be plane. For plane surfaces always radius of curvature will be infinity. That is why r1 is equal to infinity, and second surface is concave surface and it is given as r2 is equal to 20 centimeters. That is what we took here. So on applying formula, 1 by f is equal to minus of n2 by n1, that is 1.5 by 1 minus 1 into 1 by infinity plus 1 by 20. 1 by infinity plus 1 by 20. So this is minus 0.5 into 1 by infinity is always it is 0 plus 1 by 20. 0 plus 1 by 20. So 1 by f is equal to minus 0.5 into 1 by infinity is 0 plus 1 by 20, that is 0.5 minus 0.5 into 1 by 20. So this is minus 0.5 can be written as minus 1 by 2 into 1 by 20 minus 0.5 can be written as minus 1 by 2 into 1 by 20. So this is minus 1 by 2 into minus 1 by 20 is minus 1 by 40. So 1 by f is minus 1 by 40. So f is equal to finally minus 40. So focal length of the plano-convex lens is f is equal to minus 40. So in this way you need to solve the problems. If you have any doubts, you can contact me at any time. I hope this is clear. Thank you for watching the video.